Okay, welcome everyone. This is 14.1 on transversals and parallel lines. Before we get into the heart of the lesson, we have to go over some vocabulary words along with some minute details. Okay, so the vocabulary words for today are transversal and parallel lines. Parallel lines are the two lines that you see horizontally here, and they have a special characteristic because they are lines that never intersect. Okay. So they'll never, ever, ever intersect. So that means that they have the same slope. All right. They have the exact same slope. So remember back in integrated 1 or algebra 1, you learned about slope and y equals mx plus b, right? Slope, remember, is m, and they would have the same m value. Okay? So that's what parallel lines are. And what a transversal is, a transversal is a line that intersects two or more lines. In our case, our transversal will always intersect parallel lines. Okay, oops, sorry. Okay, lines that intersect two or more lines. Okay, in our case, in this section, they're gonna be parallel. All right? Okay, so those are the vocabulary words for today. And we have to learn to label them before we can talk about them. So there's multiple ways of labeling a line. Okay, so if I go back to the picture up here, right? How we label the parallel lines, we can first call them line, actually write out the word line, M, and line N. Okay, line M and line N, because there's two letters here that describes those two lines, right? And here's another notation that you guys need to know. Parallel, it looks like an 11. Okay, so if I wanted to say that line M is parallel to line N, I would just, in the middle of these two lines, I'll just write that two vertical lines. Okay, two vertical segments. All right. So that just means parallel. Okay. Or I can label these guys using the points. Okay. So I can use this first line M. I can use any 2 points here to label this line. So it goes from A to, let's say, C, AC. Okay, so I would write AC, and on the top of AC, I would have a miniature line, signifying that it's a line. Okay, so line AC is parallel again that symbol to signify parallel. I'm going to say DF. DF, and write a miniature line above it. Okay? So that's how you would note the lines are parallel. All right, and then with these two letters, I can use BC, I can use EF to signify these two lines as well. I can use AB, I can use DE. Okay, so any 2 points I could use. Okay? So just take note of that. And on the picture itself, to signify that they are parallel, you're gonna be given these little tick marks. Okay, these little arrow pointing inside the line. Okay, that makes these two lines parallel. Okay, so just keep an eye out for these markings or for this type of notation. Okay, what a transversal. So here with this line, it's line T, right? Because I have the letter up here signifying that it's that line. So I can note it as line T, or I could say line BE, right? B, that's point B, and that's point E. So I'm going to draw a little line above that and go BE. Okay, so those two are the ways to note what a transversal is. Okay, any questions on that so far? No? So the heart of this lesson is if we have a picture like this, two parallel lines are cut by a transversal, right? Then all of these special relationships, the angle relationships exist. Okay, so what we're gonna do today is we're gonna talk about each special relationship. There are actually 5 in total, okay? And we're gonna go step by step on that. But before we do start, the rule for today, okay, the if statement is if two parallel lines are cut by a transversal, okay? If two parallel lines are cut by transversal, then I'm just gonna put a dot, 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 okay? Let's talk about if-then statements. I wanna make one up right now. If I go to McDonald's, then I am definitely getting a Big Mac. What has to come first? I have to go to McDonald's first, correct? Yeah, I have to go to McDonald's and then order the Big Mac. So whatever comes in front of the if statement, I already have to have in order for me to have my then statement. Does that make sense? Yeah. If I go outside, then I'm gonna be cold. I have to go outside first, right? Yeah. So here in this statement, if two parallel lines are cut by a transversal, then dot dot dot, this picture or this already has to happen or be there. Okay, then the angle relationships exist. That makes sense? Yeah, that's the clear distinction that you guys need to know. All right. So if two parallel lines are cut by a transversal, oh, and some shorthands, okay, cut by transversal, I'm gonna label it as CBT. Just to shorthand this, okay? And I might put the parallel as the symbol. So if two parallel lines are cut by transversal, CBT. Okay? So if two parallel lines are cut by a transversal, then, so this is your first rule. It's called a theorem, but I just like to call it rules. If two parallel lines are CBT cut by transversal, then corresponding angles are congruent. You guys know what congruent means? Congruent just means that they are equal. Okay? And here is the congruency symbol. All right? That's the congruency symbol. And it just means that it's equal. Okay, so if two parallel lines are cut by transversal, then corresponding angles are congruent. So here in this picture, I know that line M and line N are parallel because of these two symbols here, right? Or I could just give it to you as, hey, you're given that line M is parallel to line N. Okay? So I took the liberty to label out all the angle measures just so that we can talk about them. And notice, class, in these special relationships, we're not just talking about the transversal and one of the parallel lines. Okay, we're going to use the fact that they are parallel in order to showcase the relationship. Does that make sense? Yeah. So, given that, I am going to make that as one group. Okay, group 1 and group 2. Okay, so one of the angles in group 1 have to be paired up with one of the angles in group 2, always. Okay, in these special relationships. Okay. Otherwise, we're not even using the fact that they're parallel lines, right? We don't even need to talk about the other line at all. Does that make sense? Yeah. If I say angle 1 is congruent to angle 4, because they are, right? They're vertical angles. I don't even need line N. Yeah. Okay, so we have to always pick from this group and from this group. Okay, one from each. Okay. So what do you guys think corresponding angles are? Give me one pair of corresponding angles. 1 and 5. Yeah. Okay. So I know angle 1 using this rule is congruent to angle 5. Does everyone see why? If you guys do not see why, imagine this group or group number 1 here, 1, 2, 3, 4, is riding down an escalator. Yeah, is riding down the escalator, and they meet group 2. Yeah, which angle corresponds to which in terms of the position, right? So angle 1 is in the same, it's in the upper left. Upper left here is 5. Yeah, they're in the same spot, essentially. That's what corresponding angles are. Okay, angle 2 corresponds to angle 6. Angle 4 corresponds to angle 8, and angle 3 corresponds to angle 7. Okay, so angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. And angle 4 is congruent to angle 8. All right? Questions on corresponding angles? Okay? Yeah. They are vertical. They are the same angle. They are congruent as well. Yeah. Yeah. Okay? Okay, so those angles are corresponding angles, and corresponding angles are congruent. That's your first relationship. The next rule we have is if two lines are CBT, or if two parallel lines are CBT, then alternate interior and exterior angles are congruent. Okay, notice that I'm shorthanding a lot of things. Okay, if two parallel lines are cut by transversal, then alternate interior or alternate exterior angles are congruent. Okay, so there's two relationships here. Okay, there's the alternate interior angles and alternate exterior angles. Okay, so this relationship along with the next relationship, the name itself gives us where it's located. Okay, so what alternate means, the first word, alternate, it means that they are alternating sides of the transversal. Okay, so what alternate means, alternate sides of transversal. Okay, they're on alternating sides of the transversal. And you can't really see that. So I'm talking about angle 1, angle 4, angle 5, and angle 8 are on one side, right? 1, 4, 5, 8 are on the left-hand side of this transversal. On the right-hand side of the transversal is angle 2, angle 3, angle 6, and angle 7, right? They're on the right-hand side. Okay, so they're on alternating sides of the transversal. Interior and exterior. Okay, what that means, of the parallel lines. Okay, are they on the inside of the parallel lines or are they on the outside of the parallel lines? All right, so if you look at the parallel lines, interior, we're talking about angle 3, angle 4, angle 5, and angle 6, right? The exterior, or on the outside, we're talking about angle 1, angle 2, angle 7, and angle 8. That makes sense? Yeah. So the description of the angle itself shows you what angles that they are talking about. Okay? Okay, so alternate sides of the transversal, or are they interior or exterior of the parallel line? All right? So now I want you guys to come up with that list. There are two pairs of alternate interior angles, and there are two pairs of alternate exterior angles. Okay? Using what we just did, try and figure them out. So alternating or alternate interior angles, that means that they have to be on alternating sides of the transversal and on the insides of the parallel lines, right? So if I take one inside angle here from this group up here, 1, 2, 3, 4, I'm going to take angle 3. It needs to be on the opposite side or on alternating sides, so 4 or 5, but it needs to be in this group. Remember, we take one from this group and one from this group, so it has to be angle 5. Okay? Angle 4 is alternate interior to angle 6. All right? Those two are the pairs of alternate interior angles. Okay? Alternate exterior angles. If you take one exterior angle here from this group, angle 1 and angle 2. So I know that there are two relationships that I have to figure out. Okay? Angle 1 is alternate exterior to angle from this group 7. Yeah? They're on alternating sides. One's on the left, one's on the right, and they're both on the outside of the parallel lines. Okay? So that's angle 7. And then angle 2 and angle 8 because of the same reasoning. Okay, so those two guys, or these four pairs, are alternate interior and alternate exterior angles. Cool? Yeah. The next one is going to go smoother because we did all that work about trying to understanding the how the relationships work. Okay. So if the rule is if two parallel lines are CBT, then same side exterior or interior or exterior angles are supplementary. Supplementary just means that they are equal 180 degrees. Okay, so that's the rule. All right, same side interior or same side exterior angles are supplementary. Okay, so same side interior, same side exterior. All right. So if I pick one of the interior angles here, like angle 3, what's the same side interior angle to angle 3? It has to be from this group. It has to be on the same side of angle 3 as angle 3. and has to be on the inside of the parallel lines. So it has to be angle 5, right? So instead of saying that, I'm going to put the measure of angle 3 plus the measure of angle 5 equals 180. Okay? Now notice, before we move on to the next relationship, notice that I have congruent here and I have an equals here. Okay? Because angle 3, I'm not talking about the physical angle, right? Angle 3. I'm talking about what degree measure it is, right? So whenever you're talking about degree measure, you always have to put the little m that stands for measure. Okay, so the measure of angle 3 plus the measure of angle 5. Now, since we're talking about numbers, right? So it's going to be equal to, not congruent to, equal to 180. So the biggest difference between what congruency does and what equals does, congruent, you're talking about the actual angle itself. Okay? This angle that I made with my finger is equal to this angle here that I made with my other finger. Okay? The actual angle itself. If I say that this angle here is 37 degrees, 37 degrees, the measure of this angle is equal to the measure of this angle. Does that make sense? Yeah? I'm not talking about the actual angle itself, but I'm talking about the what it equals. Okay? All right. So the other same side interior angle, measure of angle 4, plus the measure of angle 6 equals 180. Okay? Same side exterior angle. I'm just going to pick one from here, that first group. That's an exterior angle, angle 1. So measure of angle 1, plus it needs to be on the same side of angle 1. It needs to be in this group, right? So I'm talking about 5 or 7. It needs to be on the outside or the exterior. So I'm talking about 7. Okay, so measure of angle 1 plus the measure of angle 7 equals 180. And the other one, measure of angle 2 plus measure of angle 8 equals 180. So those guys are the same side interior and same side exterior angles, and they're both supplementary. Okay? All right? Questions? No? That's your lesson for today, class. And I hope that the name of each, if you guys took one thing out of it, the name of each relationship helps you actually find the angles itself. Okay, so that's it for 14.1.